What is linked data, and why should librarians care about it? Well, if you'll give us about 15 minutes, we're going to try to provide a very basic description of what linked data is, how it works, and why it's important for libraries. The Internet has always been a way of connecting us to various sources of information. In the beginning, that meant connecting us to documents on web pages, and the web also made it very easy to link one web page to others, giving us the opportunity to click from link to link, tracing unique information paths. Eventually, we added all kinds of other media to web pages: pictures, music, movies, any kind of document that could be accessed with a specific web address. The next step was to make the web more interactive by connecting us to services. Rather than just consume documents, we could use web-based applications to be creative. Blogging services were followed by podcasts, Twitter, Facebook, and more. To the point now where we have become used to discovering and embracing new web services on a regular basis. All of this is made possible by some very simple universal rules. The communication standard for delivering information on the web is called HTTP, or Hypertext Transfer Protocol. The way that text and other media is displayed on a web page is controlled by HTML, Hypertext Markup Language. And the way that we find any specific web page by name is with its URL, the Uniform Resource Locator. As an aside, it helps to understand linked data if we cover another term, the URI, now. A URI, or Uniform Resource Identifier, is very similar to a URL. But where a URL identifies a web page, URIs provide unique identifiers for any thing or concept on the web or elsewhere. The next wave of web development relied on a variety of technologies, including APIs, Application Program Interfaces. These are the computer programs that let you pass information back and forth as you use web services, to be an active participant on the web rather than just a consumer of documents and media. All of which is great, but there are other layers of information on the web that we don't see. Because while people have been clicking on links from the very beginning of the web, data has remained largely locked up in formats that don't allow it to be easily connected. Linked data provides a set of simple rules for addressing that shortcoming. Using the same web standards we're accustomed to, HTTP, HTML, and URIs, linked data provides a way for computer programs to more easily access, use, and remix data. Tim Berners-Lee had been actively involved in the field of linked data just as he was in the origin of the web. The principles stated here paraphrase the simple rules he gave for linked data at a TED Talk in 2009. Linked data can be used to represent anything, any concept that we can imagine. And to distinguish one particular thing from all others, each has a unique name that can be addressed using standard web technology. That name is a URI, which does for computers what the URL does for humans: define where to look for data. Next, when a program accesses a linked data URI, it returns back important information in a standard format. So if a program looks up a URI for a concept, there should be more data there that will be useful in other contexts. Lastly, the information associated with a concept must include explicit relationships to other concepts that are also described in this way. This last requirement is what transforms data into linked data. Web developers describe these principles in terms of something called a linked data triple. Start with a concept of anything. Let's say a raven. Every piece of information about a raven can be described using a linked data triple. So let's start with the fact that the raven is in the genus of Corvus, which is Latin for true crows. We've got a subject, which is a linked data URI for information about ravens. An explicit relationship is in the genus, and an object, which is another linked data URI that represents the concept of true crows. A linked data subject can have many objects too. For example, the raven exhibits an eating behavior known as carnivorous. So a URI with the information about carnivorous behavior could also be the object of another linked data triple with raven as its subject. By using many triples related to a subject, a linked data application can pull all kinds of information about it from authoritative sources simply by knowing the URIs for these objects. The data that's passed back can then be displayed in the subject service. An example of a service that utilizes linked data just like this is the BBC's Nature site. Rather than having pages of static text, the information largely comes from linked data resources on other sites, primarily DBpedia, the linked data version of Wikipedia. If you look up information on an animal, like ravens, you can scroll down and learn more about it. And if you click on something, like its classification, you can move around the site and explore related connections. The application uses text from a linked data object to provide information back to the subject based on the relationship defined by the triple. Linked data also allows an object to easily become the subject of another triple. When we clicked on true crows, that concept became the subject of the application. So now it can start its own triples, in this case linking to a news story about crows. Because the BBC Nature application uses linked data, any story on the BBC News site that contains the URI for true crows can be the object of a linked data triple from the page about crows. As human users, we're used to clicking on links like this. But in many cases, building pages and services with these kind of links requires either human editorial intervention or specialized publishing software. By using linked data, the BBC has enabled applications whose programs talk to each other using triples. So whenever a new story about crows hits the BBC News site, the Nature site will automatically know about it. So that gives you a basic idea of how linked data works. Specific URIs for useful information about concepts and their relationships. Why is this important for libraries? We'll be looking at three main reasons. First, by including linked data in the online descriptions of library resources, search engines and other information services on the web will be better able to get people directly and quickly to those materials. Second, by providing library data in more discrete, granular, and well-defined chunks, linked data allows developers to create innovative applications based on library metadata from a variety of sources. And third, linked data gives us the opportunity to think about cataloging in different, more efficient ways. It helps to remember that lots of the bibliographic data that has already been painstakingly created by libraries is already essentially in triples. Library metadata models use databases that often describe relationships very specifically, which is incredibly valuable from a linked data perspective. In this case, a library database would have no trouble exporting triples for all kinds of linked data relationships. The Raven was written by Edgar Allan Poe. It was published in 1845. It's in the genre of American poetry, etc., etc. The triples are almost transparently visible for this kind of information. Also, these explicit relationships expose another strength of linked data, an inherent ability to disambiguate concepts. A person, or a first or second generation search engine, may need a bit of context to know whether Raven on a web page refers to the bird or the poem by Edgar Allan Poe. Linked data applications, though, recognize the two as entirely different concepts, regardless of the fact that some of the words used to describe them are the same. This explicit relationship between concepts requires an agreement on an ontology, which provides the vocabulary and structure to describe concepts and their relationships. A good example of this is the schema.org initiative launched in June of 2011 by Bing, Google, and Yahoo to create and support a common set of schemas for structured data markup on web pages. You can see here how schema.org provides some syntax for describing books, as well as other kinds of creative works. OCLC has been working with the schema.org partners and others in the library linked data community to help get library metadata added to the schema.org ontology. And recently, OCLC has moved forward to include schema.org linked data in hundreds of millions of WorldCat.org records. If you now look at the bottom of record at WorldCat.org, you'll see a section labeled Linked Data. Click on that and it will bring up some text that describes the library metadata associated with that record in linked data terms using the schema.org vocabulary. If you look, you can see many of the types of triples we talked about earlier, how they describe this particular record in terms of data from many different sources. Including linked data in library records will help improve search results for those materials. Google has already begun using linked data to improve reference-style searches using a service they call the Google Knowledge Graph. If you do a search for something that includes linked data Google has connected to, it shows up as a separate section on the right-hand side of the page. If you search for Seattle, Washington, Great Pyramid of Giza, or Edgar Allan Poe, you can see some of the linked data results displayed in the right-hand column. The schema.org tags in WorldCat.org for the Raven that we showed earlier will allow search engines to clearly understand that the resource is a work written by Edgar Allan Poe and help connect searchers to those related library materials. Which is one of the really powerful aspects of linked data, that it can assemble information from many authoritative sources in one place. And because national libraries and consortia all over the world are beginning to do this, converting their bibliographic data into linked data, that means it can then be accessed, searched, and recombined by other sites and services. In addition to OCLC, the British Library, Library of Congress, the German, French, and Swedish national libraries, and the Europeana consortia have all begun to put their bibliographic metadata out on the web as linked data. And if you look at the representations of relationships within, for example, the British Library's data models shown here, you can see the links between their system in the middle and a number of other external sources shown as green ovals. Two of those resource objects, VIAF and DEWI, are linked data projects from OCLC. So as OCLC adds and updates linked data to those sources, linked data services for the British Library's collection will be improved automatically. VIAF, the Virtual International Authority File, is a good example of a creative linked data service. VIAF is essentially a merged super authority record that brings together many different names for library concepts. By linking disparate names for the same person or organization, VIAF provides a way for libraries and other agencies to repurpose bibliographic data produced by libraries serving different language communities. Which brings us to the third benefit of linked data: opportunities for cataloging efficiency and innovation. Currently, libraries build records for materials as if they are one complete standalone structure. A bibliographic record is a unique collection of data intended for very specific library-centric purposes. In order to make use of that data or improve it, you need some specific software that is largely limited to library applications. But linked data looks at information in much more granular, modular pieces, like building blocks, rather than the whole building. And these blocks can be accessed one at a time, taken out and used in other applications, managed, improved, and edited without having to address the entire edifice. And those blocks can come from any service, like VIAF, FAST, the DDC, WorldCat, Library of Congress, anything that makes linked data available using the same ontologies, which you can see if you go back and look at the WorldCat.org record for the Raven again. The schema.org tags clearly reference DEWI information and subject headings from the Libraries of Congress. The description of this work can now be seen as a collection of links and relationships between concepts. So now we can begin to imagine a world where the connections between concepts are informed not just by hyperlinks for the use of people, but by descriptive, explicit data relationships. A world where a developer could create a video application that automatically displays descriptive information taken from a text document elsewhere, which is itself a transcription of a recording from another site, and puts that up alongside a picture from an unrelated video collection. And because catalogers and other librarians are already so good at creating and maintaining data about these kinds of relationships, libraries can be in the forefront of the linked data revolution, building resources and services that help people find the information they need from as many linked, authoritative sources as possible. For more information about linked data, check out the OCLC research page on linked data activities and the oclc.org/data page. It's worth exploring the BBC Nature site, too, to get an idea of how a linked data service performs. And for a great background presentation on the subject, check out Tim Berners-Lee's TED Talk. At OCLC, our public purpose is to further access to the world's information while reducing costs for libraries. We believe that linked data is going to be an important part of achieving both those goals. Thanks for taking the time to watch.